In this given problem, H is a subset of group G and A belongs to H and B belongs to H. These A and B are arbitrary element, then their closure A dot B means there is an operation either denoted by dot or star after applying operation on A and B belongs to the set. This property is known as closure property. So a subset H of G and H must be non-empty. A subset H of G is said to be subgroup if by two-step test says if AB belongs to H, then AB belongs to H. This property sometimes we say closure property. And if A belongs to H, then their inverse also belongs to H. This property is known as closure property. So this is subgroup test, or sometimes you can say this is a theorem to prove H is a subgroup of G if and only if. This is two-step test, and you can prove sometimes by one-step test, which says if AB belongs to H, then AB inverse belongs to H. This is one-step test, and sometimes it is very important to play or prove a problem in short time. So you can apply these two tests on infinite or finite, whatever the set, but when H is finite, then we say there is another test, we say finite subgroup test, and in this if AB belongs to H, then AB belongs to H. This is only closure property. So closure property is sufficient to prove H is a subgroup if H is finite. Now according to this problem, closure property is given to you and another property given in option D, which helps you to prove inverse. So right one is D.